Okay. I think this is the one you guys were working on Friday, right? Remember this one? It wasn't this the one you were working on? I think it was. Okay, so the goal was I wanted you to, first of all, tell me what the domain is. So are there any values of x that have to be excluded? 8 and negative 8. So one thing we could say right away is that x cannot equal plus or minus 8. Okay, so there's our domain. We wanted to find vertical asymptotes if they exist and horizontal or slant asymptotes if one or the other exists. They can't both exist, one or the other. Okay, so we factored, I think this is as far maybe as you guys got, right? You factored the denominator. Right, okay, I saw a lot of people kind of moving in this direction where they factored the denominator, that's the difference of squares. Okay, the top, how do we factor the top there? What's the pattern? Bottom's a piece of cake. That one you guys could do in your sleep, but that top one, that's a pattern you might not be as familiar with. Fill in the blanks here. What's the sum of cubes pattern? A cubed plus B cubed, remember? Okay, it's going to factor into a product of factors, right? You're going to get one small linear factor and one big irreducible quadratic factor. A plus B times minus AB plus. And remember how we can keep the sign straight. First of all, how do we build the terms in the factors? Well, the first one is just, A and B is the second term. The three terms in the quadratic factor are just going to be the three ways of multiplying A's and B's. A times A times B times B, right? The signs, you'll remember this from a couple years ago. The signs go same, opposite, plus. Remember that? Okay. So then now you could tell me what's the pattern for the difference of cubes. Oops. A minus B times. There you go. Okay, good. All right, so we factor the top because it's a difference of x cubed and 2 cubed. Okay. So what does that tell us? Well, negative 8 and 8 are unique zeros of the denominator. They're not shared zeros, right? Those are zeros of the bottom, but not the top. So those are vertical asymptotes, correct? Okay. Okay, so are we going to have... Okay, so we need to know what's going on with those vertical asymptotes. Because one of the things that I saw on the board was people recognized where there were vertical asymptotes, but they weren't sure how to use the vertical asymptotes. So this would be one-sided limits. What's going to happen as we approach negative 8 from the left? Okay, what's the sign of that first factor on the top going to be? Positive or negative? We're approaching negative 8 from the left. So I just get negative 8 minus 2 is negative 10. I don't even care what the value is. I just care that it's negative. Okay, what about the next factor? Positive or negative? It's going to be positive, isn't it? I'm going to get a positive 64 plus some smaller stuff that we don't care about, right? So it's going to be positive. Now, what about this? As x approaches negative 8 from the left, what does x minus 8 become? Okay, it becomes a small negative number, which we would call 0 minus. Oh, hang on a second. Oh, sorry. That's just negative 16. Yeah, it's the next one I'm talking about. Right, so that one's just a big negative number. Okay, what about this one? As I approach negative 8 from the left, what does x plus 8 become? Okay, that's the one that's going to become 0 negative, isn't it? Right? Because that's going to be like negative 8 point something plus 8 is like negative 0 point something, right? Okay, so that's the one that we would then write as a 0 minus. So what's the overall size of that fraction? It's infinite, right? Because I've got some non-zero number on the top divided by 0, right? So that's telling me the infinity part. What about the sign? Well, we'll just follow our sign rules. Negative times positive is negative divided by positive, right? Negative times negative is positive, so I get a negative infinity. Okay, same thing. That tells me something important then. If I'm approaching this vertical asymptote at negative 8, x equals negative 8 from the left, the ant is getting plunged down to negative infinity, so we know it's bending down like that. Okay, that tells us what's going on. What if we approach negative 8 from the right? Well, everything's going to be the same except for the 0, isn't it? Because we're still just approaching the number negative 8. So I still get a big negative number for the first factor, a big positive number for the second factor on top, a big negative number for the first factor on the bottom. Only difference is now I've got something like what? If I'm approaching negative 8 from the right, that's like negative 7.999 something, right? Well, negative 7.999 plus 8 gives me a positive small number. So this becomes a 0 plus. So then what's the final outcome going to be? Positive infinity. I'm going to get negative over negative is positive, and I have a 0 on the bottom but not the top, so it's infinite. Oh, I want to do that. Okay, we'll sleep those. Did everything get moved a whole bunch? It did, didn't it? There we go. That's better. And then we're playing the same game here. If we approach 8 from the left, 8 minus 2 is positive. That's going to be positive. Okay, if I'm approaching 8 from the left, that's like 7.999, something like that. Minus 8, 0 negative. And then 8 plus 8 is 16, so that's positive. So now what's the overall sign? Negative, and it's going to be infinity, right? If I'm approaching 8 from the right, all those stay the same, nothing changes. What's that going to be? 0 plus. So I get positive infinity. So that tells me the behavior at each of my vertical asymptotes from the left and the right. Okay, now what? Am I going to get a slant asymptote or a horizontal asymptote or neither? I get a slant asymptote, and how do you know? Okay, good. The polynomial in the numerator is exactly 1 degree larger than the polynomial in the bottom, right? So if I divide these out using long division, I'd have to use long division in this case, right? I just get the result x plus this remainder, negative 64x minus 8 over x squared minus 64. So what does that tell me? And that's just a long division process, right? So what's that tell me then? What's the limit as I approach plus or minus infinity going to look like? If I look at the tails of this function, it's just going to be the limit of x, right? Okay, so you end up with the horizontal, not a horizontal asymptote, it should be a slant asymptote. Whoops. Slant asymptote at y equals x. Okay, and do we have a picture of this somewhere, I hope? No, but we can make one. Or I think, yeah, there it is. I already did it, right? Okay, does that make sense? How come that line looks so goofy? It doesn't look like y equals x. It looks like it's not a steep enough slope. Because I messed with the axes. Yeah, exactly. Okay. All right, give me thumbs. That'll make sense? Good stuff. All right. All right. Okay, how about this? Suppose g of x is a composition of function. Well, it's okay. G of x equals f of 1 minus x. So it's composition of function, sure, but for all x. They're telling us that the limit of f of x as x approaches 1 from the right is 5, and the limit of f of x as x approaches 1 from the left is 6. They want us to find the limit of g of x as x approaches 0 from the right, and the limit of g of x as x approaches 0 from the left. Okay? Well, first of all, if I'm inputting 1 minus x into f to find g, as x approaches 1 plus, what does the quantity 1 minus x approach? Right. Okay, so okay, so say that again. Okay, that's true. You don't have to see that, though, to get this right. That's true. I see what you're saying. That's interesting insight. I like that. Right, so this is going to look something like 1 minus 1.000 something. What's that going to look like? 1 minus a number slightly larger than 1 is 0 minus, isn't it? Yeah, right. You're going to get a small negative number. As x approaches 1 from the left, so I've got a number slightly less than 1, and I subtract that from 1, I'm going to get 0 plus, right? Okay. So then, would everybody agree here that the limit of g of x as x approaches 0 from the right, that's the very same thing as saying the limit of f of 1 minus x as x approaches 1 from the right. Everybody agree? Okay, we just said that. So then, what does that give me? What's my answer going to be? What's the limit of g of x as x approaches 1 from the right? Okay. Any ideas how we could do this? Well, I guess I'm trying to have you guys find anything here. Limit of f of x. It says find the limit of g of x as x approaches 0 from the right. Whoops, okay, that messed you up. That was kind of a dumb thing to write. Let me undo that. I see where the problems were coming from here. Let's try that part again. So the limit of g of x as x approaches 0 from the right is the same as the limit of what? Yeah. Okay, everybody see that's the same thing as saying the limit of f of x as the input approaches 1 from the left. Right? Does that make sense? Okay. That's just this case here, isn't it? That bottom case. Anybody get that? Okay. So what's the answer? 6. Yeah, that's 6. Okay, how about the other case? Yeah, the limit of g of x as x approaches 0 from the left. Well, that's just that case, isn't it? Right? So we're just going to get that's equal to limit of f of x as x approaches 1 from the right, which is 5.